Okay, Assalamualaikum dan salam sejahtera. So for today, we continue our lesson on boundary layer. Yesterday, we learned about the boundary layer formation. So we learned about no slip condition. We learned about the difference between ideal fluid and real fluid. And then I already explained the formation of boundary layer. So, and when boundary layer occur, so there are three basic terms that you need to really understood. So the first one is a boundary layer thickness. So it is a physical thickness, means that you could measure the thickness of boundary layer. I also show you a video about boundary layer, so you could see that boundary layer is actually exists and it can be proved through the experimental work. So means that the thickness of boundary layer is real. So it is a physical evidence. So and then there are another two terms that you need to understand. So which is the displacement thickness and also the momentum thickness. So the displacement thickness delta star and momentum thickness theta, they are imaginary thickness. So means that the displacement thickness and the momentum thickness cannot be proved with experimental works. So the basic idea of displacement thickness is to conserve the mass. So we need to fulfill the idea of conservation of mass. And the basic idea of momentum thickness, theta, is actually to fulfill the conservation of momentum. So you may refer previous notes about how to derive equation, how to derive the formula to calculate the displacement thickness and the momentum thickness. And today, we will look few questions regarding to what we learned yesterday about the boundary, the displacement thickness and momentum thickness. So before that, I hope you could refresh your memory about the relation between the differential and the integral of sine and cos. So this is the notes. I hope everybody familiar with this. So no need for me to read about this. So please, because we will use this idea in this session. Okay, so first question. Determine the delta star over delta and theta over delta for the below mentioned velocity distribution. So we have u over u with y over delta by the power of 1 over 2. We have u over u, y per delta, u over u with y over delta square. It is also known as a parabolic profile. So and then we have the power of 3, we have the power of 4, and finally we have the sinusoidal. So means that velocity profile with sign here. So this 6 velocity profile, it is a representative velocity profile in our chapter. So means that you need to really understand, you need to know to solve problem for this 6 velocity profile. So what is u over u means? Okay, previously in our lesson, we know that, so this is the brief idea on how the formation of boundary layer. So means that if you have a uniform flow here, flowing from left to right, so you will find that the velocity is not distorted, means the velocity is almost the same, it is same at the bottom and at the top here. And then while it's moving its flow on the flat surface like this, the slip condition occur, and then it will create velocity distribution. So the way it's flow along the flat plate here, so the bigger the velocity distribution will be. So and then if we make a locus, mean if we spot the 99%, the location where u is equal to 99% of capital U. So please refer to the previous notes about the definition of boundary layer thickness. So it is U, the small u here means the velocity that occur in velocity distribution here. So at point, we mark the point which small u is 99% from capital U. So this is capital U. The uniform flow or free stream velocity. And also this is also the 99% of free stream velocity. And then if we connect, we make a locus of this situation, so we could found that, so this dotted line is actually will become a boundary line, the boundary between the steady velocity, means velocity which not varied, mean velocity which has only one value. So this along at all of this area will have a constant velocity, while velocity at this area actually will vary, means it will have zero velocity at the bottom here, and the velocity will increase along the y-axis here. Okay, so means this is the boundary line. So we call here is the boundary layer. So and then, as I said, the velocity at boundary layer is actually varied. It's changed from 0 towards the value of free stream velocity, the uniform flow velocity here. So the changes here can be represented in terms of U over U, and we call this as the velocity distribution. Okay, so actually this, what happened to this? Okay, it is better for you to see this equation like this. U, small u, is equal to y over delta by the power of half here, 1 over 2 times capital U. So you must know that the small u here is the velocity which is varied in the velocity distribution. So means you have a velocity distribution like this. So this is u, the velocity that occur inside the velocity distribution. And the capital U here is actually the free stream velocity or the uniform flow. The velocity at here is capital U, and also the velocity at the maximum here, so it is also capital U. Okay, so if you see this equation, you will find that actually this equation will reflect the value of this velocity of this small u. So means that the amount of this velocity is actually is a function or a percentage compare with capital U. Okay, it is because if the value of y here is equal to delta, means the value of y-axis here is equal to delta. Okay, you know that delta, okay, please refer previous equation. So delta is actually the value of y. Okay, the value of y at 99% of capital U. Okay, let's say in this first calculation, we assume that it is almost 100% with U, mean at the point where small u is equal to capital U. So if y is equal to delta, so mean we replace this one with delta. So if we replace this one with delta, so you will have 1 by the power of square root 2 here. So the value of u is equal to u. So I hope you could understand that this velocity distribution is actually showing the value of small u here ratio with the capital U. You also know that U over U is also means of U. Okay, it can be explained as U ratio with capital U. So I hope you could understand that the velocity distribution here is actually to showing how much or what is the pattern of this small u, the velocity inside the velocity distribution change. Okay, some of them change in term of linear. So this is by the power of 1. So means that the trend is linear. So the trend may be in exponential, 1 over 2. The trend may be in the power of 2. We also call this as a parabolic profile. So we have the power of 3. We have the power of 4. And we have sinusoidal. Okay, please focus with this 6 velocity distribution because this is our syllabus. Okay, so we try to solve one of them. Okay, for example, we go for velocity profile number 1. So which is u over u is equal to y over delta square root 1 square root 2. So the first question is about to find what is the value. If you see the question here, so what is the value of delta star over delta and also theta over delta. So to calculate the value of delta star, so we know that the equation of delta star is delta star integral 0 to delta 1 minus u over u dy. So what we need to do is we substitute the value of u over u here in this equation. So if we substitute, so we have this one, and I think you know what to do. After this, you need to solve the integral problems. So we do this, integrate this one in terms of dy. So we substitute the value, the limit from 0 to delta, and finally we will get delta star is equal to 1 over 3 delta. And then we could rewrite this term into these terms. So we bring the delta from right to left. So we have delta star over delta is equal 1 over 3. Okay, so here you may check your answer whether it is correct or not. The first one is the value of delta here must be, the power is 1. So you cannot get delta by the power of 2 or delta by the power of 3 or square root delta and so on. So the power of delta must be 1. And then the numbers here must be less than 1. So if you get 3 over 2 or you get 1.77, so the value is wrong. So means you need to recalculate your equation, check back your work. So make sure that you integrate them very well. So this is the basic idea. So and then I hope you could do all you could do with other velocity profile. So we go for the theta here. So this is the velocity profile for square root 1 y over delta. So we need to calculate the value of theta here. So this is the equation for momentum thickness. So again, the idea is simple. You just substitute the value of u over u here. There are 2 u over u here with what you have in the question. So it is okay. So it's depend on the way you solve this problem. So for me, I would like to use the symbol of square root y over square root delta here. So if I replace the equation u over u, 1 minus u over u here, so you could have this term. And what I did is I just expand the terms here. So we have the integral 0 to delta square root y over square root delta minus y over delta, because we multiply this term with this term. So and then you know how to solve this. So you integrate this equation and then you substitute with the limit 0 to delta. So finally you will get 1 over 6 delta. Then you could write theta over delta is equal 1 over 6. So this is the basic idea to get the value of delta star over delta and also theta over delta. Okay, so for the second velocity profile, so we have u over u, y over delta. So this is the equation of delta star. We substitute the value here. So and then we could get delta star over delta is equal 1 over 2. So if we need to calculate the value of theta here, so we just substitute the value of y over delta in the equation. So you could solve this one. So and then you could substitute the limit here. So and then finally you will get theta over delta is equal 1 over 6. Okay, so this is the parabolic profile. So we have by the power of 2 here. So I hope you could do by yourself later. So by using the same idea, you just substitute in the equation. So inshallah, you will get the value of delta star over delta is 1 over 3. So and then the theta over delta is equal to 2 over 15. So this is the by the power of 3. So the answer is delta star over delta is 3 over 8. And theta over delta is 39 over 280. So you just substitute the value into the equation, you do the integral, and inshallah you will get this answer. So this is the by the power of 4. So the same method. So you just substitute into your equation. So you will get delta star over delta is 3 over 10 and theta over delta is 37 over 315. So please try this at home and please make sure that you could solve this one, because in boundary layer question, we always use these 6 velocity profile. And please make sure that you could calculate delta star and theta very well, because if you cannot provide the correct value, so you cannot solve the rest problem. So this is the number 6 velocity profile. So we call it a sinusoidal because it has sine. So I will show you to solve this one, because it's a special trick to solve this problem. So we know that the velocity profile is u over u sine pi over 2 y over delta. And first we need to calculate what is the value of a delta star. So this is the equation of delta star. So what we need to do is we substitute the value of u over u with what we have here. So and then if we substitute here, you need to solve this problem. So we need to solve the integral process here. So what we need to do is we integrate the sine. Okay, we integrate the sine here, so we will get cos. Okay, so and then we have problems here, because this is not a problem one, because it doesn't have any power. So the power is 1. So means that after you integrate this one, you just substitute with the limits 0, the lower limit is 0 and delta. So but what I want to advise you is please do this step by step, because if you substitute the value of 0 in cos, you will get 1 as a value. Okay, normally people will think that if we substitute 0 in any equation, the answer will be 0. So the answer is no. If you substitute 0 to cos, so you will have 1. So please be careful. Please do this step by step, because the cos 0 will give you value of 1. So and then, for example, we have a cos 0 here, but it still remains as 1. So the value of cos 0 here is 1. So finally, you will get the value of delta minus 2 delta over pi. So what you need to do, please substitute the value of pi here with 22 over 7. Okay, because sometimes students prefer to put 3.142. So actually 3.142 is not accurate. So you are advised to substitute with 22/7. So if you substitute with the value of pi here, so you will get delta star over delta is equal 4/11. So this is the delta star over delta. It's quite straightforward. So
Hello, sir. I have a question.
okay,
For the pi value, is it okay if we just key in the pi in the calculator instead of 22 over 7?
okay. The problem is you will get the value in term of decimal point. Awak akan dapat perpuluhan kan, kosong point something kan. So actually we are not favorable for that answer. Kerana normally dalam mana-mana textbook dia akan beri nilai delta star over delta tu dalam bentuk pecahan. Jarang dia beri dalam bentuk perpuluhan.
Okay, terima kasih.
Okay, okay. So we continue to calculate the value of theta here. So again, the idea is the same. So we just substitute the value of u over u here with the velocity profile that we have. So the problem here is actually it will give us a value, a quadratic value here. You will get u square over u square. So in this, the tricks to solve this problem is you need to solve it one by one. So it is to make sure that you did not make any silly mistake. Okay, so after you expand the terms here, so you will get u over u dy minus u square over u square dy. So I prefer to solve it one by one. So this, I hope this is will make clear to you. So let's say we solve the first term. So we have u over u dy. So we substitute the value of u over u here. So and then it will become like this. So and then you integrate sine, you will get minus cos. You substitute with the value of 0 and delta. Again, please do this carefully because the value of cos 0 will give you value of 1. So after you do this, you will get that the value of integral u over u dy is 2 delta over pi. So and then we solve the second terms. So the second terms here is u square over u square. Okay, please be careful because small u here is different with capital U. As I said, small u here is reflect the velocity inside the velocity distribution, but the capital U is the velocity of free flow velocity, means the uniform flow. So for the second term, okay, we have u square over u square. We substitute the value of u over u here. So we will get sine pi over 2y over delta square. So we have a problem here because every time you integrate sine, you will get cos. So if you just use the common equation for sine square is equal 1 minus cos square. So you will repeat the process again and again. You will get cos, you will get sine again and again. So it will not stop the integral process because we cannot substitute the value. So what the trick is, please remember this equation. I hope, I think you already know the relationship of this. We know that sine square A is equal 1 over 2 minus 1 over 2 cos 2 pi. So means that if we have sine square, so we have a sine pi y over 2 delta square A. So it is equal to this one. So we could replace it with it become 1 over 2 minus 1 over 2 cos 2 pi is actually the whole thing here. Okay, so and then so we have the 2 pi over 2 y per delta dy. Okay, so and then after we have this one, we could do the integral. So first we cancel out the value of 2 here. So now you have pi y over pi, pi y over delta. So and then you could integrate this easily because the power of cos or sine here is 1. So if you integrate the terms, okay, and then you substitute with the value of 0 to delta, and you will get this term, and finally you could simplify the answer as 1 over 2 delta. So because we solve it part by part, we have 2 terms. Okay, finally, please do not forget to merge them back. Means that the delta is actually this equation, and then we expand into this term, and then we substitute the answer for each term. So previously we calculate the integral of u over u is 2 delta over pi, and the answer for the second term is 1 minus 2 delta. So let the minus stay here. Okay, please do not make a mistake of this one. And then we substitute the value of pi equal to 22 over 7. So finally we could calculate that the theta over delta is equal to 3 over 22. So this is the trick for sinusoidal velocity profile. So any question for this one? Ada apa-apa soalan ke? Boleh.
So far, no problem.
Okay. Okay, so we continue our tutorial with question number 2. So if velocity distribution in a laminar boundary layer over a flat plate is assumed to be given by second order polynomial, determine its form using the necessary boundary condition. So this question is actually first, in introduction, I think I already explained that a boundary layer also has laminar, transition, and turbulent. Previously in fluid mechanics 1, we know that when water flows inside a pipe, so it will create laminar flow, it will create transition, and it will create turbulent. So same goes with boundary layer. So in the beginning, it will create laminar boundary layer, and then it goes into transition period, and then finally it will change itself into turbulent boundary layer. So now in the beginning, so we learn about the laminar boundary layer. So that's why this question stated the laminar boundary layer. So and then it asks, in this question, it asks you to develop your own velocity distribution. So the question just gives you hint. The hint is the velocity distribution is second order polynomial. So what is the idea of means that you only have one idea, one from the question. So it must be second order polynomial, and then it gives you another hint. You may solve this problem by using necessary boundary condition. Okay. So first, I think the word polynomial here, second order polynomial, is quite familiar with you because you already learned in mathematics previously. So the second order polynomial is the equation which have maximum power of 2. So mean the second order, mean the maximum power must be 2. Okay, so and then if we write the general equation for second order polynomial, you may write like this. Means that you may write u equal a plus by plus cy. So because a is the constant, b is terms with power of 1, and cy is actually the terms by the power of 2. Okay, so and then if we see the equation here, you will find that there are 3 unknown. So means A, B, and C is unknown. So means that we need to create 3 equations to solve this problem by using the idea of simultaneous solution. So now how to create your equation? at least 3 equations need to be created because we have 3 unknown parameters. So to create the equation, so you must create from the boundary condition. So what is boundary condition? So as it names, so boundary condition means that the condition at the boundary. So if you have a boundary layer like this one, so the boundary of boundary layer is we only have 2 position, 2 location which shows the boundary of boundary layer. So one is at the solid surface here. So this is the boundary between the boundary layer and the solid surface. So at this location, the second location here is the boundary condition or the boundary between the velocity profile here with the area that have constant velocity. So I hope you could understand that. The meaning of boundary condition means you need to state what is the condition at the boundary. So mean the boundary here is the boundary at the solid surface and also the boundary between velocity profile and the uniform flow velocity. So we need to come out. So let's say we have 2 location, the boundary location here. So and then we need to determine the condition at this boundary and the condition at this boundary. Okay, so let's say we go for the boundary condition number 1. So I hope you could refer to this one. Okay, this is the boundary condition at number 1. So it's stay at the bottom here. So we could write like this one. At y equal to 0, the velocity is equal to 0. Yes, Haziq? Hello? Haziq? Okay. So the boundary number 1, okay, the boundary condition number 1 is y equal to 0 and u is equal to 0. You could understand here by looking the location here. So the y-axis here is equal to 0, so the velocity is equal to 0 because no slip condition occur at this location. So and then what you need to do is you substitute the value of this boundary condition into the general equation here. So you just substitute the value of u is equal to 0. So and then the value of y is equal to 0. So finally you will get a is equal to 0. And then this is the tricks. After you know the value of a is equal to 0, means you may change the general equation here become like this only. So mean you could ignore the value of a because the value of a is already known. It is equal to 0. So means now the general velocity profile will become u equal by plus cy square. So and then, but we still have another 2 unknown parameter need to be calculated. So what we need to do is we need to determine the boundary condition number 2. So we could write as y equal to delta and u is equal to capital U. So you could get this idea by looking this location. So at this location, you will find that the y-axis here is equal to delta. So because this is the boundary layer thickness. So and then at y equal to delta here, we could assume that the small u here is almost equal to capital U. Okay, please remember that in the beginning, the definition of boundary layer is when the thickness, the U is equal to 99% of capital U. Yes, it is 99%, but in this first solution, in this laminar boundary layer, we could assume that 99% is actually 100%. It's almost means that the value of small u must almost same with capital U. So we have this idea, y equal to delta and small u is equal to capital U. So what we need to do is we substitute into this equation. So finally we could write as u equal b delta plus c delta square. So we mark this equation as equation number 2. So and then we use the third boundary condition because we don't have any point. We only have two location only for the boundary. So we just create another condition based on the situation here, based on this location. So what we could write is, we could say that at y equal to delta, du dy is equal to 0. So I think you have an idea what is the meaning of du dy because you already learned in chapter 1 about the differential method. So the du dy means there are no changes of small u according to y axis. Mean there are no gradient at all. So du dy is showing the gradient. So the gradient of du over dy is equal to 0, means the velocity is constant. There are no increment of u at all. So we make du dy is equal to 0. So then we need to substitute into the equation. So however, this equation, so it doesn't have any symbol of du dy. So means that we need to create our own du dy. So how to make the du dy? You just differentiate this equation. You differentiate u to the y. So you have du dy as b plus 2cy. So and then du dy is equal to 0. So and then you may equal it to 0. Okay, but okay, the trick is you cannot just equal it to 0. You must understand the condition here. You must understand that du dy is equal to 0 at y equal to delta. So means that you need to write like this. You need to write du dy at y equal to delta is equal to 0. And then you need to substitute the value of y here with the value of delta. Because this is the condition, this is the only condition where du dy is equal to 0. So after you do the condition here, so du dy is equal to 0 at y equal to delta. So you will get b plus 2c delta. And then you could rewrite this equation become b is equal to minus 2c delta. So and then you mark this equation as equation number 3. So and then what you need to do is you could solve this problem by looking equation number 2 and equation number 3. So you do the simultaneous solution. So you could substitute it, and then finally you will get the value of u is equal to c delta square, and then the value of c can be determined as minus capital U over delta square. So after that, you could calculate the value of b, which is equal to 2u over delta. And then finally, you just merge all the equation. So this is our general equation, by plus cy square. We substitute the value of b, we substitute the value of c here. So and then we could say that we have a small u here is equal 2u y over delta minus u y square over delta square. Then we bring the value of capital U here to the left hand side. So finally we could write u over u is equal to 2y over delta minus y over delta square. So this is actually the official and the only velocity profile for the quadratic velocity profile. Yes, for the second order polynomial is quadratic. Okay, so means that previously in question at least the velocity profile. We have 6 here. Okay, so all of this velocity profile is actually fixed. it is advantage for you to remember all this velocity profile, because if you do your velocity profile according with the idea of boundary condition, like I just show you just now, you will get exactly the same value of this one. So for example, for the parabolic profile here, okay, so for parabolic profile here, so you could see that the value is here is totally same with the answer that we get just now. Okay, so this is the value for the parabolic profile. So and then ada apa-apa soalan sebelum untuk yang ini, untuk parabolic profile? Ni Haziq ada angkat tangan, kenapa ya? Muhammad Nakib Haziq. Nakib Haziq tak ada eh? Okay. Okay, so we go for the third question. So velocity distribution for laminar boundary layer is given as sinusoidal. Determine the velocity profile using appropriate boundary conditions. So the same question. So but we need to prove, we need to show that what is the velocity profile for sinusoidal. So the same idea. Okay, first we need to write down the basic idea of sinusoidal, because sinusoidal means it involves sine and cos. So the general velocity profile is a sine by plus c cos dy. So here you could see that we have 4 unknown parameters. So mean at least you need to prepare 4 equations to solve this problem. So this is the first glance, the first idea that you need to understand by looking this general equation. Okay, so and then we start with boundary condition number 1. So at the bottom one, okay, so we could say that y is equal to 0 and u is equal to 0. So and then we substitute the value into this general velocity profile equation. So we could find that the value of c is equal to 0. So here, this is the trick. So when we know that the value of c is equal to 0, it is okay for us not to calculate the value of d, because if d is if the value of d is not equal to 0, the total value here is still equal to 0. So mean it is not worth for us to calculate the value of d. So after means that after we know the value of c is equal to 0, so we could rephrase the general velocity terms here into this one. So mean we could neglect, means we no need for us to determine the value of d. We just we just create new general velocity profile as u equal a sine by. So means we only have 2 unknown parameter left here. So and then we from boundary condition number 2, at y equal to delta, u is equal to capital U. So we could have this equation number 1. So we substitute into the general velocity profile equation. So we get equation number 1. So and then we'll use the boundary condition number 3, y equal delta, du dy equal to 0. As I said, we need to create our du dy. So this is our du dy. So and then the trick here is you know how to solve it. So you must read like this. Du dy is equal to 0 at y equal to delta. So means you need to write like this. Du dy is equal to 0 at y equal to delta. and then it is equal to AB cos B delta. You just substitute the value of y here with the delta. So, and then you could write the equation like this one. So here you need to understand that the multiply of AB with cos theta here will give you the answer of 0. So, and then, so from here, so AB cannot be 0, because if A 0 means that the value of A here is 0, you will get all the value is 0. Mean if the velocity is 0, no molecule moves. So, and then AB cannot be 0. B also cannot be 0, because if the sign B, the B here is 0, the sign will become 0, and the whole equation will become 0. So the only possibility to become a 0 is cos B delta, because cos 0 will give you the value of 1. So you simplify these terms. So you could say that cos B delta is equal to 0, and we know that cos 0 is occur at pi over 2. So we says that, okay, B delta is equal pi over 2, and then we could get B is equal pi over 2 delta. So we name this term as equation number 2. So, and then we substitute into the basic equation, because we already have equation 2 here, and this is equation 1. Okay, so and then we substitute the value of B here. So we have A sine pi over 2 delta delta. So we have A sine pi over 2. So, and then we know that sine pi over 2 is equal to 1. So, and then we could say that U is actually equal to A. So, and then this is the basic equation that we have. We substitute the value of A is equal to U. We substitute the value of B here equal to these terms. So finally, we bring the U to the left-hand side, and we could write the sinusoidal velocity profile can be written as U over U sine pi over 2 y over delta. That's why in the first question, so I use sinusoidal velocity profile as U over U sine pi over 2y over delta, because this is the correct sinusoidal velocity profile based on boundary condition. Okey, ada apa-apa soalan sampai topik ini? Okey, silakan.
Excuse me,
If
Doctor.
this one is, you don't put this one balance, yeah, both are not balanced, you know, not something. So now you have to add mass.
What? Pardon me? Walid?
Yes, Doctor. Can you go back where B delta equals to 1?
You have this one, fine.
How can we obtain
Get here.
the rest of the equation from that?
So there is
Delta
one
from equal to 1. Can you repeat your question?
then you know,
I was asking how come did we obtain sine pi over 2 equals to 1? Why did we use that one?
That's the, you know that if this is the curve of sine, so sine is equal to 0 at pi equal to 0, and at it is 0, and also at 180 degree, which is pi. So sine will give you value of 1 at pi over 2, which is 90 degree.
Oh, all right.
Okay, that's the basic idea.